forecasting, security analysis, and portfolio management. Spanning over a decade, he has varied teaching experience with participants at various levels: pre-college, undergraduates, postgraduates, and senior management personnel. He is an active researcher in the area of corporate finance and financial markets. His specialization includes the economics of investment, financing, reporting, and financial information analysis. Sir is also actively involved in teaching, research, consultancy, and training for some of the public and private entities. Sir has also attended numerous workshops, national and international conferences, delegations, seminars, and actively contributed in various committees at the administrative levels too. He has done his MCom and MPhil from Commerce Department, University of Delhi. Sir, we are very much glad that you have joined us for this session, and thank you for accepting our invite. Over to you, sir.
Thank you, Charu. First of all, my sincere gratitude for all the organizers for inviting me for this session. Uh, the topic assigned to me is the correlation analysis. Okay, so I'll move over to that very shortly. In case you have any question, any doubt, okay, I would like, okay, if it is not emergent, okay, I would like to take it, okay, slightly at the end. If you have a quick question, okay, but you can shoot me, and that's what I will try to uh, answer it. Okay, as been okay, I think okay, there is some issue. Okay, uh, okay, I will also be okay switching off my video. Okay, that will actually help me stream it much better. Otherwise, my bandwidth will actually be giving me a problem. Okay, so let's start for the day. Good morning, one and all. I hope your session at the course okay, are proving to be quite informative and useful to you all. Let me just share my screen and move over. Begin with the day. Mm, the question. What is the measures of association?
Narayan, sir, your voice is breaking in between.
Hello.
Hanji, sir.
Narayan sir, it's still not audible and there's a vibration coming. Uh, a request to all the participants that just bear with us. It is not audible right now. Sir is looking into the problem and then we can start. So it's still not audible even to us. We are looking into it.
Narayan sir, if you're speaking anything, we can't actually hear. There is a vibration sound at the background.
I think Anjali, call Mr. Narayan and tell him.
Sir, maybe if you can try rejoining again. Sir, we still can't hear you. There is a buzzing sound, I think.
Better now?
Yes, sir, very much.
Okay, just let me know in case still the situation is persisting. I think okay, it should have been resolved by now. Okay.
Yes,
Okay.
sir. Yes, sir. It's audible as well as visible.
Yeah, sure. Okay, so let me again go through what I've been just talking about. Okay, so things moving fine. Okay, so what I've been going to talk about today is okay, very simple tool in a multivariate framework, which is the measure of association. One, how does one variable relate with another set of variable? Okay, so what is that degree, the extent, okay, and dimension of that kind of a relationship? That's what we are looking at in this measure. And regarding the basic tool which we are going to talk about, okay, this is such a basic tool that almost okay many a situation, whether you do your structural equation modeling or whether you do your simple regression analysis, uh, at the back of the entire structure, you still have this measure of relationship or correlation, okay, at the back working for you, okay, in devising your research experiences or analysis for your research work. Okay, so this being such a basic tool, but okay, I'll try that you get something new, okay, to learn from that. There's always a new day, and there is always some new experience for you in the store. So okay, I hope that there's some more value addition happens on this basic part of the analysis as well. What is this structure around? Okay, this actually relates different sets of variable, more than one variable, because we don't talk about an association with itself. Okay, so that's not what we are referring to here. In this case, what we are referring is, okay, you do have one variable and you are looking for how does how does that particular variable relate with some other variable of your interest? And if that serves your purpose, okay, entirely in itself, okay, that is for sure. Otherwise, okay, you can actually take the analysis forward and go for certain more complex relationship in between them. But the basic one still remains the same, that it happens to be your measure of relationship between the set of variables. Just to give through some examples to okay, in this area. Okay, I'm picking up one example from the finance itself. So how does a credit rating, for that matter, okay, of the IPOs relate with the uh, whether the subscription happens to be okay, oversubscribed or not? So you can have, okay, suppose that there is an IPO which has happened, okay, and whether the IPO is fully oversubscribed, okay, more than the requisite number, or it's undersubscribed, or it is exactly fully subscribed itself. So whether the subscription, whether it's under, fully, and over, okay, it does relate with the ratings of the instrument. So if your security is a pretty high rated, which is a AAA rating, or okay, uh, very okay, lowest level of rating itself. uh, so is there any relationship? Okay, so if the ratings is high, okay, that does that result into certain oversubscription of the security or not? Okay, I'm just giving one such example for doing this kind of analysis itself. Okay, the set of okay, the under, fully, and over, okay, that's not simply a nominal version. Okay, and again, the ratings is also not a nominal version. But in this case, okay, is there any relationship between these two? So if, as a regulator, as the Security and Exchange Board of India, okay, insist on having a higher rating, okay, and if you do have not higher rating, but okay, get your securities rated, does it really help to investors, okay, in making their decision regarding the IPO investment or not? Okay, does they relate to each other or not? Okay, or the rating will simply add to the cost of subscription, and that will result into a higher cost of uh, the issuing of security itself. Okay, so that's what we okay, that's what we could relate. Okay, if we are looking for these two variables. Okay, so the IPO subscription vis-a-vis that of a rating of the instrument. Secondly, okay, as one more example which you might think of, okay, do you think that the credit card has boost up your purchasing power? So having a credit card, easy access to your okay, borrowed capital. Okay, this is your borrowed money, which you are borrowing it from the bank. So do you really think that credit card, okay, helps you to purchase more? Does it help in your um, uh, purchasing power, in enhancing your purchasing power, in boosting up your purchasing power? Okay, so you might have questionnaires, okay, on built around this question, and okay, you are simply been asking various respondents regarding what they, how do they feel about their purchasing power, okay, if they are holding a credit card. And you might try to relate it with another set of variable. Okay, do you feel that you are been buying okay, more than while using a credit card? Okay, so do you suffer from this overbought situation? Okay, so is this a buying and overbuying, okay, an excessive buying, which you might think of? Does it relate with the credit card okay, usage as well? Okay, and not just that you are holding it, but okay, you also feel that that is going to help you in your purchasing power as well. Again, okay, you might relate it with okay, certain scale, okay, which you have been built upon in this case as well. Okay, so is okay, your understanding, your okay, effective okay, relationship with respect to the holding of the credit card, okay, does help in your buying behavior. Okay, it would rather okay, overbuying. Okay, does it really result into an overbuying or not? Okay, so can you relate these two relationship, okay, these two variable in 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 a particular context? Okay? That's what again you can also relate with your correlation analysis as well. Okay, and there are many more. Okay, I'm just giving two such examples on this itself. Okay, but there could be many more on this aspect itself. Okay, so what's going on? Okay, I think there's still some Good morning. Okay, so moving on, okay, from that aspect, I think somebody raised a hand as well. Okay, it's not visible to me. Yeah, okay, somebody was trying to ask something.
Sir, would you like to take questions now? We'll take it up at the end.
Okay, okay. If it is not emergent, okay, so then I'll we'll take it at the end.
Okay, sir.
So if something is clarificatory in nature, something is which is emergent in nature, okay, I'll take up on the spot. Okay, otherwise I'll take it at the end. Okay.
Yes.
Okay, so all these relationship, okay, all these analysis which we are looking at, okay, for various variables, okay, they are referring to the degree, direction, okay, and the strength of relationship between the set of variables. Okay, does the rating helps the investor? Does holding a credit card, or what do you feel about holding a credit card? Not just that you are holding a credit card and it's lying in your in your vault, okay, and then you are not simply been doing anything about it. That's a different thing. But if you are holding carrying a credit card, does it really help you in buying, okay, in your purchasing power? And this help, okay, in your enhancement of the purchasing power, does it really result into an overbuying as well? Okay, so you might end up overbuying something, okay, with these digital instruments, okay, whether that helps you in your buying behavior or overbuying behavior. Okay, does that really result into that? That could be certain sets of example, and there could be many which you might relate to in this case. Okay, so does even in this context, okay, having the number of cases of COVID, okay, does that really affect your IIP numbers, index of industrial production? Does it really help in your stock market, and so on and so forth? Okay. So when we are talking about some of these variables, these relationship, okay, what we are looking for, that there is some sort of an association between these variables, okay, and we are just putting certain index, certain number to that, okay, which shows you, which signifies the strength of relationship, okay, the degree of relationship, and the direction of relationship. So it's a negative or it's a positive. That's what we are referring as the direction of relationship. The degree of that relationship, okay, how much they have been positively or negatively related. So that's also the aspect, okay. And what is the significance? What is the strength of that kind of relationship? It's not that you are getting a number which is 0.1, but it's okay, the relationship, okay, but it's virtually, okay, almost equal to zero itself. Okay, so is there any strength in that relationship, any significance in that relationship as well? Okay, when you are using these measures of association, this is what you generally look upon, okay, in the case of a variable. Now how the two variables, okay, the basic premise on which this has been built upon is how the two variables are related. Okay, that's what we are generally look at. It may be a linear relationship, it may be non-linear relationship, okay, but mostly you encounter a set of linear relationship, a measure of linear relationship between the two variables, okay, but there could be non-linear relationship as well. Okay, I'll talk about some of those issues in today's session as well. Okay, so any measure of a relationship or a correlation represents the mutual relationship between these two variables, which we are primarily looking up, okay, between uh, the sets, okay, which you have picked up for your relation analysis in that case. Okay, why I'm simply been putting up only the two variable case, okay, which can easily be extended to an n variable case as well. Okay, but primarily, okay, this still relates at the immediate basis that the relationship is only among the two. Okay, you can in a multiple correlation analysis or even in a regression, you have more than two variables to relate to. Okay, so there's a combined association, but again that still been, okay, computed from your two variable case only. Okay, looking for some of these measures of association, okay, we have okay, this co-movement, co-relationship, this between the variables, okay, studied in the context of their behavior, which are, okay, synchronous to each other, sympathetic to each other. So correlation is a study of covariance between the variables, okay, and this is some sort of a sympathetic movement among the variable itself. Okay, so either in the same direction or in the opposite direction. So direction might change, but this is the movement is okay in terms of okay it's not simply the mean level differences. We're looking for the variation. So if some variable changes, so change in x1, okay, that's what we are referring as a variation, and simultaneously due to the change in x1 the x2 is also being changing, so there is an x2 change. So are these changes okay somewhat signifying any sympathetic movement, okay, or not? So it's not just a level change which we are looking at. Okay, we are referring for the okay any variation which is okay guided by, or it is simultaneously represented by the two variables. Okay, why I've been associating this with that itself, because suppose there's a variable x1 and there's a variable x2, the x1 variable still remains the same throughout. Okay, so I ask you, each one of you, okay, each one of you draw a circle, okay, and you measure, okay, with whatever radius you are free to choose. Okay, you draw a circle, measure its circumference, and divide it by the diameter of the circle itself. Okay, that's my variable one. Okay, so just the participant one, participant two, participant three, four, and so on and so forth. Okay, each one of them are been measuring the circumference and dividing it by the diameter, and you are getting certain values. While x2 is okay, how much confident you feel about okay, about attending this workshop itself. Okay, so on a 5-point scale from 1 to 5 itself. Okay, and we are measuring this kind of a relationship, and we know that the first one, okay, is not going to have any impact on the second one. Okay, why is it so? Because the change in x1, okay, and what is the number which you are going to get? You will be only going to get a value of pi 3.14. Okay, so circumference divided by diameter is your 3.14159.265. Okay, that number is not going to change from one respondent to another set of respondents. So there's no change in x1 which has been there. Okay, so whenever you are talking about a relationship, we do look for a covariation. We are not looking for okay simply a one-to-one association of how the x1 is affecting x2. That's not what we are referring to. If there is any change in x1, okay, how does okay that change is sympathetically being considered with the change in the second movement itself. Okay, so when two variables are moved in sympathy to each other, okay, in synchronous with the other, okay, we refer to that there is some sort of an association which has been there between the variable. Okay, and this associated with a change in the other variable, okay, which may be in the same direction or maybe in the opposite direction. So you can have a positive relationship, you can have a negative relationship as well. Okay, this degree and the direction is pretty much important. Okay, and the direction of the movement, okay, could be represented by the sign, okay, positive or negative. So that still okay remains as okay one aspect, which is the direction of relationship. The degree of relationship is okay in terms of what is on a particular scale. Okay, on a scale of generally -1 to +1. Okay, how much the relationship is been there. So if it is more on the positive side, okay, +1 number, okay, or in absolute sense, okay, if it is more towards the value 1, okay, you have a higher degree of relationship. If this absolute value of the correlation is more towards the 0, okay, you are having a okay somewhat lesser degree of relationship in that case. Okay, so the relationship between the variable may be strong, may be weak, okay, and different degree of correlations are possible, okay, which could be there. Why did this kind of a measure itself? Okay, because we are trying to standardize it, okay, from the perspective of the unit in which these measures are actually being devised. Okay, so your correlation number is independent of the unit of measurement. Okay, so if you have a series x1 and you are actually been measuring the weight of each one of you, or each one of you in each one of the participant in kilogram. If you compute the mean will also be in terms of kilogram. If you compute the variance, that will be in terms of kilogram square. If you compute the standard deviation, that will still be in the kilogram. Okay, so whatever is the unit in which you have measured the variable, okay, that unit persists in some of these measures of central tendency or the dispersion. But correlation, okay, is independent of this unit of measurement. So correlation will never be in terms of kilograms. Okay, so don't even put that number in that case. Okay, so so the relationship, okay, among the variable could be linear or could also be non-linear in nature. Okay, so the relationship so far, what we have been talking about is that there is a measure which can actually compute, okay, a degree and the direction of the relationship, okay, between these two variables. Okay. And I'm not specified, I'm not qualified my statement by saying that the relationship which we have been measuring is only the linear relationship and not a non-linear one. You can have okay, a non-linear relationship as well. But quite often you end up looking for these measures, okay, doing some sort of more complex mathematical procedure only on the linear one, not on the non-linear one. Okay, but yes, there does exist, okay, a measure of relationship which can also talk about in terms of the non-linear relationship between the variable. Okay, okay, let's talk about some of these classification of these correlation coefficient correlation measures as well. Okay, you can have a bivariate relationship, which is that means you are only having two variables to make a relation. Okay, you really want to make a comment on the relationship between the variable, which are only two in terms of number. Okay, and if you have more than two, we are referring in a more of a multivariate framework itself. Okay, probably multivariate is for bivariate as well. Okay, but we are putting a classification which is even greater than two, okay, as our definition for the multivariate itself. When there are only two variables, okay, there's nothing, okay, that's not much of a scope for any variation. So we do have a simple bivariate correlation between the variables. Okay, while in the case of a multivariate, you can have multiple correlation, you can have a partial correlations as well. Okay. Okay, so somebody is asking, is there any difference between association and correlation? Okay, association is a much wider term. Okay, in most contexts which we use it. Okay, so you can have a measure of association, which is quite a larger, okay, vein. Okay, correlation happens to be a smaller set in that case. Okay, we put certain restriction on correlation that it is only a -1 to +1, though there are measures of association which may or may not be following this kind of a limit as well. Okay, so and there are association, there are correlations which there are rules of association which can even go beyond the correlation as well. So at a higher level, probably you can also put copula as one of the way of measuring this kind of an association. That's mostly in the context of a continuous time as well. Okay, but that can be okay more of a measure, okay, for a association rather than a correlation in that case. Okay, so association is a larger vein. It's a larger concept. Correlation, okay, we try to specify in a very much standardized way, okay, of these measures as well. And your correlation could also be for linear and non-linear one too. Okay, okay, so coming back to your correlation, okay, so you can have it between the two variables, okay, or more than two variables. And if it is more than two variables, so you can have a partial multiple correlation, or you could have a partial correlation as well. Okay, so now one very important aspect regarding this entire discussion on correlation is, okay, another aspect, which is causation. Okay, so is there any relationship between the two? Okay, our general principle is yes. Okay, I'm just putting that as a overarching statement. Okay, so generally there should be a relationship between the correlation and causation, because that's a premise on which you are actually been using the entire structure. But okay, I am saying, okay, this is a general rule, but the rule also has an exception. Okay, so you have to be pretty clear about that, whether this, okay, what you are trying to infer from your correlation analysis, is it really justified on logical statements as well, or theory as well. Okay, correlation can be computed even in uncorrelated, okay, variables which are not causing each other at all. Okay, so you can compute a correlation even that case. Okay, but will that really justify that your correlation is coming from the causation side or not? Okay, that you really need to be pretty careful in that case. Okay, These two concepts could be quite orthogonal. Okay, one may not be dependent on the other. Okay, but when you try to do your research, okay, the implied assumption in your research happens to be that yes, correlation should be okay manifesting the causation. If you are relating two variables and with a reasonable belief, okay, as to that the relationship to exist, okay, so you try to infer that by correlation analysis that there is some sort of a relationship with causation, which is these variables have been sharing among themselves. Okay, you are yet to explore that what could be the causes of those relationship, but okay, you tend to believe that probably if they are been causing each other, then in that case, okay, you should be having an implication, okay, a manifestation in the form of the correlation coefficient. Okay, so causation or causality, okay, is the capacity of one variable to influence the other variable. Okay, so if you put okay, okay, more amount of urea, okay, the yield should have been higher. Okay, if you pump more amount of money into the economy, okay, the interest rate should be effective. So one should be causing the other one. Okay. However, correlation by itself does not imply causation. Okay, you hope that the correlation imply causation. Okay, that's your hope, that's your belief, but that may not always hold true. Okay, and one of the reason for that is okay, there might be a third factor which is really been responsible for the influence on both the variables as well. Okay, so that could also happen. Okay, I'll give you an example on that as well. Okay. So correlation is different from causation, okay? But you do hope in your research that correlation is manifesting a causation, okay? Like 99% okay of the time, okay? If not 99, probably 90% of the time, you try to think that the okay your correlation analysis is manifesting the causation which has been there within the variables itself. Okay, so you continue to assume that kind of relationship. However, that may not always hold true. Okay, so correlation is when two and more variable or things, okay, they tend to occur at the same point in time. Okay, while causation is, as we said, okay, defined in the above statement, it's a capacity of one variable to really influence the other variable. Okay, but the two okay, which this correlation may or may not be connected with your cause and effect relationship, so that might still be there. Okay, uh, you do have okay in the context of okay that this what I was referring primarily from a simple perspective. Okay, but you do have the partial and the multiple correlation as well. Okay, where when you look for the variable, okay, so either they have been explaining them together, which is your multiple correlation. Okay, while if you have been only concerned about an exclusive relationship of one variable with the other one, we are referring to a partial one. Okay, but that will only happen in the context of more than okay, two variable which you have been relating. Okay, I'll come back to it. Okay, shortly once again. Okay. Talking about this correlation and causation, okay, in somewhat more greater detail. Okay, let's take this example. Okay, this is one of the most cited example. Okay, so the ice cream sales, okay, and the number of shark attacks. Okay, if you take two variable, you have variable one and variable two. The variable one is the sales of the ice creams, okay, and the variable two is the number of shark attacks which has happened on a beach. Okay, and if you just see the kind of okay that's kind of a behavior, okay, over a period of time. Okay, so you have in the month of January, February, March, April, May, June, up to December. Okay, you have the entire 12 calendar year, okay, months, okay, in this case, and the sales of each of these months are being given, and the number of shark attacks is also being given. Okay, so that means if you try to relate these two, if you compute a correlation between these two, okay, you are going to get a much higher correlation, okay, greater than 0.8 or something. Okay, so can we infer, okay, here that because you are getting a pretty high correlation about 0.8, okay, that the ice cream sales leads to the shark attack. Okay, and if you think this way itself, okay, and probably that's where you are making a fault in terms of the causation itself. Okay, So both ice cream sales, okay, as well as the number of shark attacks, okay, they happens to be higher, okay, when there is a summer, okay, around April, May, June till September, okay, so that happens to be higher, and then after that, okay, these number of variables are actually going down, but the what is important in that case, they have been co-moving, okay. If one is going up, the other is also going up. If one is going down, the other is also going down as well, okay. So there is a co-movement which is actually been happening, as a result of which the correlation is also pretty high, okay, greater than 0.8. But can you really infer causation on the basis of that? Because you find a pretty high correlation, okay, among the variable, okay, that you will not be able to, okay. Though you really be looking for what okay, which one of them, okay, is actually helping explaining the other one, but that's not will not be able to explain you on logical ground, okay. Why is it really so? Is okay, because of the fact that, okay, when there is a summer, more people go out, okay. When these people go out, okay, the ice cream sales, okay, is likely to go up, okay. And when they go to the beaches, okay, there are instances that the shark attacks happens on the seashore, okay. So it's not the ice cream sale which has been affecting, okay. It's some other factor, okay. Probably, okay, people okay, habit of enjoying the good weather, okay, is really causing both of these variables to occur simultaneously, but one is simply not causing the other in that case, okay. One of the okay fallout for, okay, and probably that's what you will be relating in most of the time, and you do have the corresponding concept of applicable in the regression model as well, okay. So whenever most of the time when you see your series which happens to be non-stationary series, okay? So when you have a non-stationary series, okay, you are bound to get this kind of relationship, this kind of spurious uh, correlation results. Okay. This will happen because it's simply affected by the temporal movement in your analysis. Okay. Second, okay, this is an example where you do see a very high correlation, okay, but that's not supported by causation. Ice cream sales are not causing the shark attacks. Shark attacks is also not causing the increase in the ice cream sales. Okay, so there's no causation between them, okay, but you see a pretty high correlation between them. Now let's take an example which is an opposite in nature, okay, and that's why I will be able to infer that two are orthogonal, okay. One is not, okay. The concept of correlation is quite different from the concept of causation as well, but most of the time you are looking for probably the two are coming in the same spirit itself, okay. Okay, so causation may not always imply correlation as well. Okay, so now let me take an example where there is a correlation, there is a causation between them. Okay, and okay, however, that's not been reflected, that's not been manifested by the correlation coefficient. Okay, there's a typical example. Okay, comes from your behavioral sciences. Okay, in terms of the stress and the performances. Okay, so some amount of stress is desired only when you try to perform. Okay, so if okay, I didn't ask for that there is going to be a test at the end of the refresher course, okay, or there is going to be a test at the end of the semester, okay, nobody is going to study at all. Okay, so people, okay, really okay, need some minimum level of stress, only then the performance happens. So if everyone is been left, probably there is no going to be, okay, any of these tests, okay. So probably you will not read, you will not try to score as well, okay. But if I give you, okay, a 15 assignment per week, okay, and each assignment having a tenure of okay, okay, a period for 3 hours each, okay, probably there is too much amount of stress and your performance will actually go down. Okay, you try to perform, but that performance will actually be going down as well. Okay, so this will be happening. So stress, okay, has a dimension which and there's a positive dimension, we call them as U stress. Okay, and there's a negative aspect, okay, negative side of the stress, we call them as distress. Okay, so yes, okay, there is a positive stress, there's a negative stress, but there's a pretty profound relationship between the performance and the level of stress which you have been having. So there is some optimum level of stress which has been needed to have a maximum amount of performance as well. Okay, the two are very much related. Stress does cause the performance. Okay, there's one of the factor at least, okay, causing the performance among the individual. But if you try to compute a correlation between them, Okay, you can just simply try, okay, this kind of an exercise, that correlation between performance and the stress, okay, that you will come quite closer to zero number. Okay, well, the limitation is that probably correlation, which you have been measuring, is a measure of the linear relationship between the variables. Okay, so the linear relationship between these two happens to be not been there. Okay, so you know, okay, from the theory that yes, stress causes performance. Okay, it's very much causality which has been existing in these two variable, but okay, the correlation which you are able to compute is, okay, simply negligible. Okay, so here you are not able to, you know that there is a cause and effect relationship, but the correlation in that case is not been okay, manifesting that kind of a relationship as well. Okay, so two variables causing each other but doesn't share any correlation coefficient, any significant correlation coefficient. Okay, and unlike an example where there are two variables not causing each other at all, okay, and they share a pretty high correlation coefficient. Okay, so this is something which, okay, you should be taking care of whenever you are doing this kind of analysis. Okay, and that's why I intend to put it, okay, straightforward, that okay, whenever you do this kind of analysis, okay, you do take into consideration these kinds of relationship. Okay, but when I'm giving you these two extreme situations, okay, causation, okay, correlation but not manifesting the causation, and causation, okay, not getting manifested in terms of correlation, okay, that can happen. Okay, but let me not over obsess you with the exception. Okay, but there is a rule. Okay, and the rule is that, okay, the causation should be getting manifested in terms of correlation. Okay, and that's you typically assume in your analysis. Okay, so that still holds true most of the time. Okay, if there is a causation, okay, if there is any correlation, there must have been some causation. So if you try to include, okay, let's say stock of money supply in the economy and the level of interest rates in the economy, okay, yes, they do causes each other, and the correlation should also be pretty higher as well. That should be getting manifested in terms of your correlation statement as well. Okay, so as a general rule, this should hold true, but then there are exceptions to this general rule. Okay, causation may not get manifested in terms of correlation, and okay, in the previous example, correlation may not be manifesting that there is a causation between the variable. Okay, so that you need to be careful when you do this kind of analysis as well. Okay, okay, so okay, so the difference between multiple and partial, I'll come to it, okay, shortly. How to measure causation? Okay, so as far as the measure of causation is concerned, okay, it's an abstract concept. Okay, and the measure of causation is theory. Okay, so you don't have any numerical number, okay, of causing the one. Okay, it's only the theory which can tell you about. Okay, and that's why the importance of academics has been there. Okay, you build around the theories. Okay, if you are able to build good theories, okay, which can help you, okay, why the one is causing the other itself. Okay, it helps to explain this kind of a, okay, cause and effect analysis as well. Okay, so that's what you should, okay, you can take help, okay, rescue on that aspect itself. Okay, okay, so okay, so I'm saying, okay, so stress always result into a okay, performance. Okay, so okay, the common parlance is probably, okay, we are sensitive more towards the negative aspect. Okay, so whenever you listen to the word stress, okay, you always associate with the distress itself. Okay, but yeah, it's a quite value neutral word as well, stress. So stress could be, okay, positive, use stress could be distress as well. Okay? So there are a dimension on both the sides as well. Okay. Okay, so regarding okay, the measure of correlationship, okay, so the measure of correlationship, okay, yes, there are multiple ways in which you can measure the correlation, but if you talk about in terms of a measure of causation, which I just talked about, okay, you don't have a direct, okay, measure in that case. That's a more abstract version. Okay, and theory is the only way in which you can look for, okay, why the one is causing the other. Okay, for example, okay, if I'm saying the money supply should affect the interest rate, okay, so you really need to work on how does the IS and LM work Okay, entire the Keynesian economy is a framework has been working. Only then you can actually explain why the one is causing the other, why the money supply is causing the interest rates to move. Okay, so that's the only way in which you can look for these causation based analysis. Okay, but regarding the correlation, okay, these measures which can help you to fine tune your causation. Okay, you can take help of the correlation set of analysis. Okay, so as a rule, okay, the correlation and causation should move hand in hand. Okay, but I'm also giving you an example that don't get obsessed by this rule. There are exceptions to that as well. Okay, so as far as the correlation analysis is concerned, there are multiple ways in which you can measure correlation. So you can have a line chart. Okay, you can have scatter plot, you can have various statistical measures as well. Okay, so some of these are graphical one, line chart or scatter plot. Okay, or you can have statistical measures for doing that itself. Okay, so let's classify these measures of a relationship, okay, based on the data type. Okay, I believe, okay, you might already heard of these data types. So you have four such basic data types. Okay, which could be nominal, okay, ordinal, okay, interval, and the ratio level data set. So we have this. Okay, let's talk about the basic one, the nominal data type. Okay, and what is the measure of relationship in that case? So don't, okay, quite often, okay, you end up having these relationship. Okay, you're studying these relationship. Okay, and you always relate that there's only one measure, which is a Pearson correlation coefficient. Okay, there are more than that as well. There are more measures rather than on this aspect too. Okay, so you can have measures for nominal, ordinal, ratio, and okay, in the interval as well. So as far as, okay, the nominal data set is concerned, okay, there is something called Kramer's contingency V, okay, coefficient, okay, which you can also compute, and these are there in the SPSS as well, okay, where you can compute the measure of correlation shape, okay, measure of a relationship between the data set, which is nominal only. Okay, so if you're looking for nominal and nominal, okay, then in that case, the correlation coefficient which you can compute in that case is a Kramer's contingency coefficient V. Okay, so here, okay, what is the Q and what is the phi number? Okay, which has been actually been put up here. Okay, and numerator and the denominator that's been there. Okay, so you prepare your contingency table. In the contingency table, you compute a chi-square coefficient divided by the number of observations. You get your numerator, and when you divide this by, okay, the minimum of a number of rows and the columns minus 1, okay, so that becomes your denominator, and that's how you will be able to compute, okay, your Kramer's contingency number as well. Okay, if there's no association between the variable, okay, I'll not call, okay, correlation in more, okay, concrete framework here. Okay, V happens to be 0, and in case there happens to be perfect association, the V happens to be equal to 1. Okay, so that will be considered, okay, in this nominal data set correlations as well. Okay, regarding, okay, whether okay, we can implement that, okay, in your SPSS too. Okay, but regarding, okay, whether the number which you have been getting, okay, is really able to okay, make some sense, okay, as far as the interpretation is concerned. Okay, so you have certain rules of thumb, okay, applicable in this situation. Okay, so when you have, okay, pretty lower as index value, which is 0 to, let's say, 0.1, okay, we are saying it's a negligible association, okay, between, okay, 0.1 to 0.2. Okay, these are all okay, certain subjective limits which have been set forward. Okay, sorry. Okay, regarding the what is the degree of relationship, okay, and is that degree, okay, really useful for my work or not? Okay, so when you are getting a value greater than 0.6, okay, you in most of the social sciences, okay, you seems quite comfortable in terms of inferring about that. Yes, okay, one is getting impacted by the other. Okay, if you are able to justify the causation, okay, in that case. So you'll put up a range of values regarding these kinds of behavior too. Okay, the computation wise, okay, if you look for that, okay, so suppose you are looking for that there's a nominal okay, scale which is only can have two values, whether you are agreeing or whether you are disagreeing. Okay, nominal. Okay, in the sense, okay, whether you assign 1 to disagree and 0 to agree, okay, it doesn't have any sort of implication on whether you assign agree to 1 to agree and 0 to disagree. Okay, simply you are simply being numbering them. Okay, these various variables. Okay, similar to that, your male and female. Okay, so you have been simply been coding in them as M or F. Okay, or 0 or 1 or 1 or 0. Okay, hardly matters. Okay, these are the two nominal scale. Okay, but if you're looking for, is there any relationship between opinion and the gender? Then in that case, okay, you are not using that the classical, okay, the more ubiquitous measure of this of the Karl Pearson coefficient. Okay, here these are only nominal, okay, variables, and the measure of relationship and association between them, okay, you can compute from the Cramer's V. Okay, so you compute your observed frequencies, okay, which have been there, and you have your expected frequency. So this is O, this is E, okay, observed and the expected ones. Okay, you take a difference of observed and the expected one, square them, okay, divided by your expected one. Okay, that's where you will be able to compute chi-square. Divide the chi-square by the number of observation, which are 150. You get your numerator of V, which is pi square, and you divide it by, okay, minimum of number of rows and number of columns. So there are, okay, there are only, okay, there are 2 columns and there are 2 rows. Minimum of 2 and 2 is only 2. Okay, so 2 minus 1, that's your denominator. You divide it, you take a square root, you get your value, which is, okay, 0.25, okay, which is your Cramer's V. This is what you could use, okay, which, okay, generally been used in the case of a nominal data set. So we are not computing a, okay, Karl Pearson coefficient in this case. Now, going forward, if what you could use for the ordinal data set, okay, so there's another measure of okay, the correlation between these ordinal data set, okay, where there is a Spearman's correlation coefficient or the Kendall's tau, okay, that's what you could also use in these cases as well. Okay, so when there is no correlation, okay, how can we formulate hypothesis on that? Hypothesis is not hypothesis is not built upon, okay, it's not been okay, hypothesis is not been built upon on correlation. Okay, so you are not saying anything on the correlation. Okay, you build your hypothesis based on what, okay, research objective you are looking for. Okay, so should money supply be affecting the interest rate or not? Okay, that's what you should be computing, rather than, okay, you are computing a correlation and then you have been computing the or building a hypothesis around that. Okay, okay, so okay, so regarding the second sets of measure, which are the measure of okay, association, correlation among the ordinal data set. So there you can have okay, measures on Spearman's correlation, okay, as well as the Kendall as well. Okay. So if you're looking for ordinal level data set, not a nominal one, if you're looking for ordinal level data set, then you can use a Spearman's rank correlation coefficient. Okay. So basically the idea is, okay, the variable is converted into a rank. Okay. Second variable is also converted into the ranks. Okay, and then you compute a correlation among the ranks itself. Okay? That's what the Spearman's rank correlation is actually been doing. Okay, so this can actually help you to compute correlation among the ordinal level data set, not okay, the nominal level. Okay, so for nominal level you cannot use. Okay, you should not use this. Okay, too. Okay, so there's always a gradation. Okay, you have nominal, ordinal, interval, ratio. Okay, so whatever you can use for nominal one, you can use it for the ratio and interval one. Okay, but whatever you could use as a, okay, any sort of measure for, okay, the ratio or the interval one, you cannot use it for the, okay, the downgraded okay, data type itself. Okay, nominal and ordinal will not okay, they will, you cannot, okay, or it will not make any sense, okay, computing a Pearson correlation for nominal or ordinal level data set. Okay, So Spearman's rank correlation is one tool which you can use for your ordinal level data set. You could also use the candles tau or as one more measure of the correlation among the data set. Uh, a candles tau is a much preferred tool of analyzing the correlation when your data set is pretty small. And there are more tied ranks in the data set. If it is not there, then probably the rank correlation which is given by Spearman can actually suffice your set of analysis. But if you have a data set which is small, and as well as when you have a tied ranks, that means ranks are same for multiple observation, then in that case it's better to use candles tau as one more measure. Uh, okay, let's take one example in this case. That's a classic example given in Andy Field's text itself. I'm also taking up from that book. Does the creative people are the world's best liars? So there's a competition, of who gives the best lies, and if the person's is able to satisfy the judges, yes, this is the best lie, which the person has spoken, the person is been awarded. So there is also a first prize, second prize, and third prize. And is there any way in which we can measure the creativity of a person as well? So there are questionnaires built around the testing of creativity. So so is the creative persons are best liars, or not? Can we relate to this itself, and can we relate this kind of a data set and have yes, creativity has to do something with the ability to lie in a perfect fashion. So the perfect lie, if you could make it. I shared one data set with you all, and that's what I can just simply show it. The biggest liar, that's the data set which I shared with you all. I simply just run it in terms of the candles tau and how you interpret it in the SPSS as well. So let me just use that data set and show you how we are computing and how we have been interpreting that number itself. Just open it. Okay, so regarding what is this? The dividing line among the what is considered as a strong relationship, what is the weak relationship. It is just a matter of convention. We have been slightly more liberal in terms of social sciences. But yes, these are subjective. It's subject to the interpretation of the researcher. So there's nothing which you can put it as a sacrosanct. Something like saying that what is the large sample and what is a small sample. Theoretically, if you ask me, a large sample is where the number of observations are infinity. But if you take this definition, you will not be able to work on any data set because there is no data set which has an infinite number of observations. So the principle of the central limit theorem will never apply to any data set because n is never been infinity. But you take as one of the measure of convention that yes, 30 could be set as a demarcating line, but it's a subjective line, and not mathematically proven number as well. But yes, you have picked up something over as a matter of convention. Similar here. What is a dividing line? What is the correlation between how a much high correlation is actually a good correlation? So there's no it's just matter of convention that which we have been defining in that case. Kendall's tau, okay, which has a C number, which is concordance, okay, and discordance, which has been taken up, okay. Okay, but okay, they are so much iterative in the sense that okay, to implement it on without software will take too much amount of our time in this case. Okay. Okay, so okay, so this is my data set. Okay, so these are certain number of participants which have participated. Okay, so on their scales of creativity, you have these numbers. Okay, so first respondent, okay, creativity score 53. Second respondent, creativity score, okay, 36. Third respondent creativity scores 31. Okay, and you have positions. Okay, whether they get okay, first position, third position, fourth position. Okay, this is also your uh, the winning. Okay, in the case of a participant. Uh, so first, second, third position is the position in that contest. Okay, where you are supposed to lie, and probably whose lie is the best lie. Okay, as per the judge's opinion. Okay, has been given the first prize, second prize, and third prize. Okay. So if we're just trying to relate to the correlation, okay, I can go to analyze. Okay, in SPSS, I go to analyze, then I have correlate. Okay, I pick up bivariate correlation. Okay, and here I take creativity as one of my variable. Okay, and the position. Okay, in the contest, that's as my okay, second variable. Okay. Mathematically, okay, it will ask you for, okay, but probably it can compute anything, okay, on the Pearson correlation as well. But you have to be taking your call, okay. These are ordinal data set, okay. You can only say creativity, okay, score which has been higher is a more creative person, okay, rather than the person having a lower creativity in that case, okay. So that's what you can relate creativity and the position. Uh, in the your competition. Okay, that's again your ordinal level data set. Okay, so someone given a first position, okay, is a better liar as compared to someone who's been given a second position. Okay, so you have to take a call. Software will not help you to take a call that what is the appropriate coefficient in that case. Okay, so we know that these are your ordinal level data sets. These are not your ratio level data sets. So okay, the coefficient which can make more sense is a Kendall's tau and Spearman. Okay, Pearson is not going to give you a probably that's not an appropriate coefficient which you can pick up in this case. Okay, so I opt for Kendall's tau. I can opt for the Pearson correlation. Okay, and I can press OK, and then see my results in this case. Okay. Okay, so how to interpret these results? Okay, let me come back here. So regarding these results which we are having, the correlation between these two, okay, the position obtained in the in the competition and the creativity of a person. If you relate these two, the coefficient in that case happens to be minus 0.3. Okay. So slightly lower, okay, but that's a kind of relationship, okay. So higher is the creativity quotient number, okay. Lower is the position, okay. And obviously, the lower position actually means that the person is a better liar, okay. That's why negative relationship is still being the one which you can think of as a desired one as well, okay. Because if your position is second, your position is third, or your position is one, the first position. A first position is a better liar. So higher the creativity, okay, and the chances are that the person is going to win the liar's contest as well. Okay, so the relationship is negative. It's a minus 0.3. Okay. Regarding whether it's a statistically significantly different from zero or not, is it equal to zero? That okay? Can we say that okay, due to the sampling, okay, a procedure, you got something which is a non-zero number. Otherwise, okay, it belongs to okay a group, a population where the correlation happens to be zero. Is it really so or not? Then okay, and then in that case, okay, you can refer to your significance level. the significance level is 0.001, less than 0.05. Okay, so probably you are able to reject the null hypothesis. Okay, and what is my null? My null is that my population is having a zero correlation. So that's what you could also read it from. Okay, so this is something of a number. 0.03 is something, a number which is not coming up from simply a sampling error. Okay, there are larger support. Okay, there are larger statistical evidences to support, to reject my null hypothesis that there is no relationship between creativity and the competition position which has been obtained by the various respondents in that case. Okay. Uh, it's a symmetric one. Okay, so whether the creativity or the competition position or position versus creativity are going to get the same answer. Okay. That's based on the Kendall's tau. Okay, and you have the Pearson's correlation as well. Okay, so where you have correlation which is again minus 0.373. Okay. So if unless there are the number of observations are the number of ties are more, okay, which you can look at from your frequency table as well. Okay, along with that the sample size has been small. Okay, then Kendall's tau makes much sense. Otherwise, Pearson's also gave me same answer. So you are still getting a minus 0.373. Okay, which is also statistically significant as well. Okay, your p-values are less than 0.05. So you again reject the null hypothesis. So you do have a relationship between creativity scores. Okay, the creativity has an impact on the position which has been obtained by the respondents in the competition. Okay, so that still is that getting validated, statistically validated in terms of your position from the data set as well. Yes, creativity does help you win a liar's competition. Okay, simple stating in that fashion. Okay, so okay, so talking about the next set of correlation coefficients which you can actually compute for interval level and a ratio level data set. Okay, in this case, yes, you do have your Carl Pearson coefficient of correlation, which is the one which you can use it for the ratio or the interval level data set. Okay, that makes much sense for those kinds of data set. Okay, not for the nominal or the ordinal one. Okay, if you have any cross data set as well, we have tools for that too. So the formula, I think that is one of the widely used formula for computing correlations, which is based on the product moment. It's a covariance divided by the standard deviation. So you compute a covariance between the two variable x and y, and you divide it by the standard deviation, product of the standard deviation of x and y, and you get your correlation coefficient. Okay, again you have some guiding principle that what is a strong relationship, what is a weak relationship in that case. Okay, and we are reading it in terms of the absolute value. Okay, so that what could also be used for as far as the relationship is concerned for a scale level data set or an interval level data set. Regarding the whether they are coming up as significant or not, that you have to be slightly careful and look for the various assumptions on that basis itself. Okay, let me take if there are any query in this case. Okay. Okay, so probably I could answer most of this here. Okay, nothing. Carl Pearson is only for measuring linear relationship. Yes, okay, I'm coming to some of those assumptions as well. Okay. Okay, so let's come to the testing of the correlations. Okay, so how does how we are going to test for whether the correlation which we have been obtaining is really significant or not. okay, or you have simply been computing okay, the correlation which you have been coming up, okay, when you use the data set, you churn the data set, you get one number of correlation. Is that number the index of the correlation which has been thrown, okay, by the software or by any of these okay, data crunching exercise? Is it really not coming up from the sampling error just because you picked up a sample of a certain, okay, type or certain size or certain context, that you are getting certain strong correlation? Otherwise, okay, there's no correlation between them. Okay, if you're really been interested in testing that, okay, then you really need to be, okay, at least for the ratio level, okay, we are talking about that you need to be worrying about the assumptions and biases which have been built around that as well. Okay, so when you are looking for correlation, particularly Carl Pearson correlation, okay, you really need to work on, okay, these assumptions, okay, whether that's been validated or not. So one of the assumptions for the these is there's a linearity. Okay, so there's a linear relationship between the variable. Okay, so if you're looking for, let's say, the money supply, okay, and the interest rate, okay, are you really looking for the linear relationship between money supply and the interest rate, whether positive or negative? So linearity is the one aspect, okay, and that has to do with the model validity as well. Okay, is your model valid or not? Okay, so that's one assumption. So when you're really been checking for the testing for the correlations as well, you need to be worrying about, firstly, okay, whether there's a linear relationship or non-linear relationship, and secondly, you also need to be worrying about whether the distribution is normal or not. Okay, because these tests which you are going to use it, okay, the underlying for most of these tests is, okay, that your test population, okay, parameter statistics which has been distributed as normal. Okay, so is it really normal or not? Okay, so is the normality assumption okay, valid in a particular data set or not? Okay, or it has only small sample property. Okay, okay, normality, okay, is really important when you do have your small sample. When you have a large sample, obviously you have something called as central limit theorem, okay, which can actually, even a non-normal population, okay, in terms of their sampling distribution, can be okay, taken a rescue, okay, with the help of a large sample. Okay, the normality may not be such an important issue at all, but it is a pretty important an issue when you have a small sample. Okay, and why this normality is needed is because you want to conduct a hypothesis testing. Suppose you don't want to conduct a hypothesis testing at all, okay, then you may not again need a normality assumption as well. Okay, but what to do with these as well? Okay, what is a way out for checking these? Okay, you can go for some of these okay, graphic okay, or non-graphic ways as well. You go for the simple linear plot, scatter plot, QQ plot, PP plot, histograms, okay, to able to, okay, giving you some sense, okay, whether the relationship is linear or not. Okay, so you can simply have interest rate and money supply. Look, you can look at the graph whether there's a linear relationship between them or not. Okay? At least you get some sense in terms of these relationships. And secondly, with regard to the normality, okay, you can again prepare your QQ plot, PP plot, or histogram, which again can help you infer whether there is some sort of a normality. Though there are refined tests as well, okay, Jack-Pera test, okay, Kolmogorov-Smirnov test, Lilliefors test, okay, Kremers okay, and so on. There are multiple of such tests which are also being there. Okay, if there are, okay, these assumptions of linearity, normality, if these assumptions, okay, are being actually being met, and there are no biases which has been left, okay, go ahead, go for Pearson's coefficient computation itself, and also interpret its hypothesis tests which are also been built around that, whether the correlation is equal to 0 or not. Okay, but if these assumptions are not being met, there's no normality. Normality is not been present in the data set, or they are high outliers. Okay, the sample size is very small. Okay, then in that case, okay, you really need to go for, okay, some other procedure itself. Okay, normally, which is okay, researchers don't study more. Okay, don't give up more stress on that as well. Okay, so you can bootstrap it rather than computing as okay, assuming an okay, distribution which is normally, okay, given by the theory. You can have a bootstrap confidence interval. You can okay, use Kendall's tau. Okay, remember if there are more tide ranks which were in there, you can look for Spearman correlation. Probably if your normality is a more of an issue, then in that case, okay, bootstrapping is a much better procedure. If there are more amount of outliers in your data set and you are not able to, okay, you don't wish to move them out from, throw them out from your data set as well, then okay, you can go for rank based correlations measure, which are Spearman's rank correlation and Kendall's tau. So that you really need to be doing. So this check, okay, this testing check you should be doing when you have been going for the correlation testing itself. Okay, so regarding the test procedure, again the SPSS throws you the output. Okay, what is the correlation between them? Similar to the one which I've shown you for the rank correlations as well. So it throws you an output. It throws you the significance factor. It throws the number of observation along with the correlation coefficient. So you simply need to interpret that as well. Okay, but you should be aware about the probably what this software has also been doing at the back. Okay, so it's been computing the standard error, okay, by this formula, which is 1 minus correlation divided by n minus 2. Okay, it computes the test t statistics, okay, and that gives you the value as shown by the output as well. Okay, so if you take the same example, which is I think okay, the same example here. Okay, if you instead of going for the bivariate analysis, if instead of Kendall or Spearman, if you go for Pearson, okay, I don't recommend using a Pearson one for these number, okay, because these are your ordinal level data sets. Okay, so it again is giving you some sort of your correlations, okay, their significance, and the number of observation. Okay, so what is that significance? What is the t number which has been computed in this case, which is r upon the standard error, and what is the standard error, which is 1 minus r squared divided by n minus 2. Okay, so that's, you should be aware that probably that this is what actually been done at the back. Okay. Okay, so this is a more desired position, okay, as far as okay, when you are actually been testing, okay, the simple t-test which you actually been using. So the correlation, the null in this case happens to be that population correlation coefficient is 0 against the null that the population correlation coefficient is not 0. Okay, if you're doing this kind of a test, okay, then it is okay. This has been a more preferred choice. Okay. However, if you're looking for a non-zero null hypothesis, okay, what I've been saying that probably you want to test that the correlation coefficient between the two variable is, let's say, 0.5. Okay, we're not looking for rho is equal to 0, but 0.5. Then in that case, okay, the t-test based, okay, the procedure which I shown you, okay, earlier, okay, is not a preferred recommended procedure. In that case, probably you can go for Fisher's transformation based correlation testing itself. Okay, so transform the R into Z, okay, and transformation is happening by this equation, and then you test it for in this case. Okay, again the procedures, okay, softwares are there to help you out in this case as well. Okay. So that's a preferred choice. Okay, Fisher's transformation. This is actually called as Fisher's transformation. Okay, base procedure is a better choice. Okay, when you are looking for a non-zero, but most often, okay, quite often, almost in 90% cases, you still go for testing whether there is some zero correlations or not. Okay, if that is the case, okay, the previous procedure can help you in that case. Coming to the multivariate correlations, okay, so probably when you have more than two variable and then you want really been interested in relating them, okay, so that's where these partial and multiple correlation can come into the picture. Okay. What is by definition, how does the partial correlation coefficient has been working? Okay, it's been relating one variable, let's say y, okay, with another variable, let's say x1, when the influence of all other variable x2, x3 and all other are actually being removed in the equation. Whenever you compute a correlation between y and x1, okay, you are actually been ignoring that whether these variable exist. Okay, so whether x2, x3, okay, are existing, okay, in the universe or not, that has nothing to do with your computation of correlation between y and x1. But when you compute a partial autocorrelation, okay, then what is actually being done is you compute a correlation between y and x1 given, okay, that you have filtered out the effect of all other variable which might be existing in that case. If you do it that way, okay, you are able to compute something called as a partial correlation. Okay, and what is there in the case of a multiple correlation is that, okay, you simply compute that what is the correlation between y, okay, and all these okay, variable x2, x3, sorry, x1 included, x1, x2, x3, x4 taken together as a whole. Okay, so what is the correlation of between y and, okay, probably taken together as a whole is your y cap itself. Okay, but in any case, okay, all the variable taken together as a whole, okay, and how does that relate with one variable of your interest? Okay, that's where you have a multiple correlation coefficient. So here all the effect taken together is accounted in the case of multiple correlation coefficient, while in the case of partial correlation coefficient, you only see an impact between y and x, okay, and removing all the impact of all other variable in between. Okay. Uh, there are mathematical formulas, okay, on that itself. That's what now I'm not stressing on that, okay, but probably I'll show you, okay, how you are actually been, okay, how does this actually make sense, okay, for you to interpret as well. Talking about, okay, the example of your multiple correlation is your R square, which you generally used in a regression model, and it has to do more with the model fitting. Okay, so the multiple correlation coefficient, which you generally use for your analysis, is in the form of your R square, which you get in your regression model. Okay. Regarding the use of partial autocorrelation, okay, so there is standard, okay, one standard example given in the textbook, which talks about the prominence of your partial correlation coefficient. Okay, so suppose, okay, I'm just giving the same example to you as well. Okay, suppose you are a school principal, okay, and you have really been interested in, okay, the okay, that your class 10th or 12th scores, okay, number of students who pass out with higher okay, scores, okay, should be higher in your school as well. This is what you have been interested as the principal of the school. Okay, so you took certain data set, okay, and you find that, okay, you have IQ score of the student and how much they score in your, okay, set examination. Okay, it's the Western, okay, the scholastic aptitude test. Okay, and you can go for your 10th or 12th marks as well as a proxy for the Indian contextualization. Okay, so you have high IQ, high class 12th score, and the relationship is pretty high, 0.8. This is your simple correlation, not a partial one. Okay, we are all talking about in the partial, sorry, simple correlation, not partial. You also have your creativity questionnaire as well. So you computed the creativity quotient, okay, and you okay, also related computer correlation between them with your class 12th marks, which is very low. Okay, and when you compute that, is there any relationship between IQ and the creativity, which is also pretty low as well. Okay, so this is not something which you can control as an principle. Okay, how does the creativity and the IQ is been related? Okay, that's generally a given, a standard number. Okay, and probably they will be sharing a lesser number. People who are more creative, okay, may not be having so much amount of their, okay, the testing constructs in the IQ test, standard type IQ test. Okay, so you will not have much of a control on this. So the only control which you can have is, as a principle, is, okay, that either you only admit students which have high IQ, so that their class 12th marks is very also higher, or what you could also do is, okay, okay, having admitted those students, you can build on, okay, enhancing their creativity skills, okay, as a result of which, again, class 12th marks can also be impacted. But this is a higher one, this is a lower one. So as a principle, okay, probably you should be only admitting student which is having a higher IQ, and should not be wasting your resources in terms of time and money and energy, okay, on the enhancing the creativity of the student. If you use this data set to try to, okay, solve the problem, okay, which the one of the head of the institution is actually been facing, okay, you might interpret it this way. Okay, so creativity, enhancing creativity skills of the student is not going to help you, okay, if you simply take your decision based on these simple analysis. Okay, but if you compute something called as a partial autocorrelation number, okay, what is that's been showing? So what is the relationship between your, okay, we are taking a proxy of class 12th marks board examination to standardize the examination scores. So class 12th results and creativity, and if you control for IQ, okay, so that means those students whose IQs are the same, Okay, so they are having the same IQ of, let's say, let's say 100. Okay, so they are, let's say, 5 per student. Okay, having A, B, C, D, okay, E, and each one of them are having 100 IQ. Okay, so their mental age and chronological age is exactly the same. Okay, so if their IQ is the same, and then from only for these sets of a student, if you compute what is their creativity quotient and their class 12th scores, okay, then there's a pretty high correlation which is been obtained. Okay, this was actually been obtained in that Western study, which shows you the significance of using the partial correlation in that case. Okay, so that means if you filter out the effect of IQ of a person, IQ of the student, okay, if the person is more creative, gets a higher, okay, SAT score, a higher class 12 score. So what we are doing, what's wrong here, and what's wrong, okay, what is, okay, getting benefited here. This is for all students, okay, whether their IQ is the same or not. But what this is trying to tell you is that, okay, if you are able to control the effect of IQ of a student, then creativity as a, okay, icing on the cake, as a top up on that itself. Having more creativity is going to fetch more marks in the board examination or in standard public examinations as well. Okay, so this way, the importance of partial correlation is more prominently being discovered. And after that, there were a lot of studies which was saying, okay, probably the creativity skills in the school should also be highlighted, okay, in the curriculum. So that's where, okay, you have one such application which was there for the partial autocorrelation. Significance of partial autocorrelation for partial correlation. Autocorrelation will be more of a time series data set. Okay, so partial correlation, okay, will be more important in your analysis, in your data analysis itself. Okay, so multiple correlation I already talked about. Okay, this is generally we use it in your regression, okay, as a more of a goodness of fit criteria, okay, where all variable taken together, let's say, okay, how much of IQ and how much of the okay, creativity as a whole taken together helps you explain the class 12th score. If you're looking for in that case, okay, you are using a multiple correlation coefficient for conducting this kind of an analysis. Okay, so there are a few more correlations as well. Okay, again, the computation and number, they are all nowadays been handled by the softwares. Okay, so probably only for reference purpose, if you are looking for that. Okay, so yes, some of these can actually be pretty helpful. Okay, when you take a correlation, okay, between a variable, let's say x1 and x2, and where one of these variable, okay, where one of the sample which has been measured is dichotomous, can only take two values, okay, that's a male or female, okay, or pregnant or not pregnant, dead or alive, okay. If only can take two values, that's dichotomous, okay, then what you could use is a biserial correlation coefficient. Again, SPSS gives that as well, okay. And when your variable is, okay, is strictly dichotomous, then you can use point biserial. Okay, so you can also say, okay, the economy is a developing one, okay, versus a developed one. Okay, so here you are really not sure. Okay, not okay. Yes, there are some countries which you can easily put into a bracket which is a developed countries. Okay, for example, US. Okay, you can simply put one of these countries which okay, you can really put into a developing one as well. Okay, which you can also put India. Okay, but not every country. Okay, you will be able to put it in a straight compartment itself. Is it a developing one or is it a developed one as well? Okay, so if you are not sure about many of these, okay, then okay, biserial correlation can actually work. But if you are pretty sure, okay, yes, okay, you are able to bifurcate into two groups, okay, dead or alive, okay, you are not been in between in that case, okay, then you can use point biserial correlations as well. Okay, this is one variation. Then for those who are actually been looking for and were trying to, okay, seek an answer as to that, if there is a non-linear relationship, something like stress and performance, okay, the relationship is not linear, it's a non-linear one. then what to do? Okay, can you use correlation in that case? Yes, you can also use correlation for that. But you need to resort to somewhat more mathematically more complex technique, Box-Cox transformations. With Box-Cox transformation, suppose your lambda happens to be 2. And the graph which I was showing you was more of a parabola. And parabola look like a is your quadratic equation having a square number. So if your lambda happens to be true, then your stress, performance and your stress can be non-linearly related, and you can again get your uh, 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 correlation coefficient in that case as well. So with Box-Cox transformation, you can also measure the non-linear relationship as well. At times, this transformation can also help you to handle non-normality as well. By these transformation, normality can also be resorted. But I'm not saying that this is a panacea for all problems. So it will always be able to help you with the non-normal data and non-linear data. I'm not saying that, but yes, at least you have something to work on in this direction. So if you're looking for non-linear relationship, computing R square with a non-linear relationship, then you can use this Box-Cox transformation, and it can also help you handle the non-linearity as well. Yes, you can also have a spurious correlations, which basically means that there's no causation, but you're still getting a correlation. That I already talked about. So before I actually wind up, that was all the content I have for you for today. I can take your questions if you have any. So the extent of relationship between one ratio of variable and other qualitative variable as well. You still have those contingency matrices. If you are having nominal versus the ordinal. Remember here, by the guiding principle was anything which you can use to compute a correlation on as a measure of association. Let me put it this way. Any measure of association which you can use it for nominal level data set can be used for ratio level data set. But every tool which you can only use for ratio level data set cannot be used for the nominal level data set. So that gradation you need to keep in mind. So something which you can actually use as a tools of analysis for the nominal level data set can also be used for the ordinal level as well. So if one of the variable is nominal one, so use the nominal tool. And that can also handle if the other happens to be a non-nominal one, let's say interval or ratio level. But if something which is if none of your variable happens to be a ratio 1, so then in that case you should not be using the Pearson's number as well. So that guiding principle you have to be keeping in mind itself. It's better to have both the variables of the same data type, but if it is not, anything which has been applicable for any one of them. So suppose one is a nominal one, the other one is a ratio one. So, so whatever is applicable for nominal one can be used for the ratio one as well. But not vice versa. So that thing you need to keep in mind. So let me take some more question. Ratio and thing. What does negative values implies? Negative values, if you are referring to the correlation coefficient, it means that the relationship between them happens to be a negative one. If you have gender and creativity, so gender is a nominal one, and creativity is an ordinal one. So then whatever is applicable for nominal one, Cramer's V, you can use it. Again, I insisting on the same point itself. Something which is applicable for nominal one can be used for the ratio one. Can also be used for the ordinal, can also be used for interval, can also be used for the ratio one. But one tool which has been there for the ratio scale level data set, should not be used for an interval, ordinal, or the nominal one. That guiding principle you have to be using. So if you have 4 permutations and combination, so, 4 combinations rather, so 4 C2, if you have been looking in that case, so you can choose based on whatever has been applicable for that minimum of the two scales. Okay, so if something is an ordinal versus interval, okay, so any tool which is applicable for ordinal one, okay, you can use it for your analysis itself. Okay, non-linear relationship. Okay, I already talked about. You can look for the box cost transformation. Well, Kuljit is asking, okay, what is bootstrap confidence interval? Okay, there's something called as bootstrapping and jackknifing. These are two statistical procedure, which is generally when resorted when you do have your non-normal data set. Okay, so then a bootstrap procedure is generally being implemented. Okay, probably what exactly is that? Okay, will take a lot of our time in this case. Okay. How do we do partial correlations, okay, in SPSS? Okay, so instead of where I went for analysis and I went for correlate, and then I opted for the simple bivariate correlation. Instead of bivariate correlation, you can opt for the partial correlation. So that will also be able to compute. Okay, help you. Okay, what is Granger causality? Okay, that has more to do with the time series data set. Okay, so I'm not commenting on that. Interpretation of correlation value for Pearson. Okay, you can refer to Andy Field's book. Okay, it's a pretty decent book. Discovering statistics using SPSS, discovering statistics using R, discovering statistics using Python. Okay, and so on and so forth. So you can refer to some of these. Okay, Andy Field is a pretty good book in these cases. Though there are a Palette. Okay, Juliet Palette. Okay, one more good book in this area. Multiple, probably. Okay, there's no dearth of good books in this, at least these okay generic areas where you are actually been looking for. If one is a non-linear case, how to interpret the following data? Okay, I really don't know. Okay, probably what you meant by okay this -1. You do need okay and the understanding. Okay? Nobody can actually interpret it for you unless the person knows about it. Probably what is the nature of the variable and what you have been trying to relate it. Okay. For ratio level, okay, for nominal level data set, I think I talked about that you can use the Kramer's V okay, technique for that. What is coefficient? I don't know which coefficient. Okay, so the Kendall's Tau, if you have been more interested, okay, Krishna Kumar, okay, probably you can again refer to the Andy Field's book, okay, it talks about what is concordance and discordance, C and D, okay, these are the two numbers and can use for the Kendall's Tau computation as well. Okay, so probably you have a lot of okay, inputs on that as well, okay, but because this is quite iterative, it's not as simple as taking a difference, squaring it, summing it, okay, and then you process it, okay. So it's going to involve based on the changes in sign. So you compute concordance and okay, opposite sign, you call them as a discordance. Okay, and then you are able to compute the candle star. Okay, that's also with the help of this as well. Okay. Mostly done by the softwares now. What is PP and QQ plot? Probably that has more to do with the normality testing, okay, which is what I was not referring to. Okay, probably you can refer to percentile plot, quantile plot. Okay, that's what you could also, or probability plot versus quantile plot. Okay, that's what you follow for the PP plot and QQ plot. These are graphical measures to check for non-normality. Okay, so probably you can search on that aspect to how to test for non-normality, and that's what you can have referred to. Okay, what is the meaning of saying bootstrap it? Okay, I already talked about. You refer to bootstrapping procedure when your distribution happens to be non-normal one. Okay, and what is exactly that procedure? It's again an iterative procedure to generate sampling distribution, not theoretical one, but an empirical one. Okay, so from the data set, you are computing that. So probably for these, okay, you can refer to some of these advanced texts, okay, and including Andy Field also talks about the bootstrapping procedure for testing that as well. Okay, so you can refer to those itself. Fisher transformation, again, those okay are ways. Okay, it's more opted for, more apt for testing a correlation coefficient which happens to be a non-zero. So if you want to test whether correlation is equal to 0 or not, okay, your simple t-test will suffice. But if you're looking for your correlation coefficient is 0.5 or 0.7, okay, then the Fisher's transformation is actually being resorted to. Okay. More on that, okay, you can refer to some of these texts which I also already mentioned. I think I could answer most of your queries which have been there on the Q&A.
Yes, sir. I think you have answered all the queries which are there in the Q&A box. So thank you so much, sir, for this great session. We had a really wonderful and learning session with you about the correlation, covariation, and where these measures should be used, the concepts of bootstrapping and multivariate correlation, partial correlation, etc. We are really grateful to you, sir, for joining us on the board for this session. Thank you so much, sir. And thank you very much on the behalf of Teaching Learning Center, Ramanujan College and Indian Accounting Association, NCR chapter, for being with us.
Thank you. Thank you, Jaro. Thank you,
Thank you,
everyone.
sir.
Thank you, sir.
Participants,
Thank
the
you,
link.
Pushpapanji.
Thank you, sir. Participants will come back for the next session after 20 minutes. So please join for 5 minutes before the next session begins. Thank you.